Hola, mis amigos y amigas chileanos. My name is Heidi Stefanyshyn-Piper, and I'm a former astronaut from NASA. And I'm going to talk to you about space and what it was like in space. And I'm going to do that by telling you my story. So, my story starts where every other story starts with my family. I'm one of five kids. I have four brothers. My parents came to the United States from Europe. My mother's German, my father's Ukrainian. And what they really wanted was the American dream for their children. They wanted their children to be successful. And you know what? A lot of success starts with education. And so I did really well in school. I did really well in high school. So when it came time, I knew that I was going to go on to college. Decided on mechanical engineering, applied to a number of different schools. And one of those schools was MIT. But tuition does cost a lot. So I looked at different options for paying for school, and the Navy came out to be a good option. And I said, okay, I can spend some time in the Navy. I wanted to be a pilot, and that was my dream. Finished my degree, got my master's degree, only to find out that I had failed the eye test and I couldn't become a pilot. So the time I said, okay, I got to find something else to do. And other options, Navy diving. I grew up in Minnesota. I can swim. Thought, why not? Well, it was a lot more than just swimming in a lake. But I thought, you know what? I can figure this out. It was hard physically. You work out a lot, but it's amazing what you could achieve when you're determined to do something. So I finished dive school, went out into the fleet, and I loved what I was doing. I was fixing ships underwater, had the opportunity to do some very, very interesting salvage jobs. And at that time, I learned about the NASA astronaut program. Found out you don't have to be a pilot. I had relative work experience. I was fixing ships underwater. NASA was going to go build a space station in space. So I figured, okay, let's apply. First time around, I got a letter back that said, thank you very much. By this point, I learned a lot of astronauts don't get selected the first time. And so I applied a second time. And sure enough, that's when I got the phone call from NASA that says, please come down to Houston. We'd love to have you in the astronaut program. And so I did. So before I get too far ahead, let's get up into space. And so this is the launch of my second flight, STS-126.
Vehicle's in good shape, the weather's beautiful, and so on behalf of the entire shuttle launch team, good luck, Godspeed, and have a happy Thanksgiving on orbit.
Endeavor's ready to go. Endeavor OTC, close and lock your visors and initiate O2 flow. That is in work.
So that was your first 2 minutes of flight. You saw those main engines light. They light 6 seconds before liftoff, but it's those solid rocket boosters that get you off the ground. They burn for 2 minutes, they're jettisoned, and we continue up another 6.5 minutes using just the main engines. The external tank that provides the fuel for the main engines, once it's expended, we don't need it anymore, so it's jettisoned, and now you're in orbit. And so we go ahead and start reconfiguring the space shuttle for time in orbit, and we can go ahead and start getting out of our seats, getting out of our suits. It takes a little bit of time getting used to space. You'd think floating around would be really cool, and it is. But when you have work to do, you have to think about now, how do I have to work in space? Because it's not like standing up. When you're floating around, you're less stable. But, you know, humans are pretty ingenious, and we all figure it out within the first couple of hours. And then it's time to go to work. Both of my missions went to the International Space Station. This is what it looked like after the last shuttle mission left. My flights, we were still constructing the space station. And by doing that was being done with a combination of using the robotic arms on the station on the shuttle to lift up the piece of hardware. But then we would go ahead and send astronauts outside to do the spacewalks. And that's doing all of the final assembly and getting the equipment ready to be deployed. If you notice in this picture, everything outboard or to the left of the astronaut, that was all brought up on the mission. And so doing the light things like hooking up cables, the power cables, data cables, that's just much, much easier to have an astronaut do that rather than to have that all be mechanized. This contraption that we have to swing into place eventually becomes the solar panels, but the equipment has to fit inside the shuttle's payload bay. And so everything is all tight together and everything's very secured. You have a lot of straps and nuts and bolts and plates holding everything together so nothing's damaged during the launch process. And then, like I said, we go outside and we start systematically removing bits and pieces, putting things into location of where it needs to be for the activation and for the time on orbit. So now you're getting to see more of what's going to become a set of solar panels. And that's actually me. That's my helmet camera. So that's what I'm looking at. And you know, when you're outside, you just have to take advantage and look over the side and look at the beautiful Earth going by. Now, jumping ahead a little bit, on my second flight, I got to do spacewalks again. But the second mission was very different from the first one. The first one, we were construction. We were building up the outside of the space station. The second mission, we had a lot of supplies in the inside, but we had to do repairs on the outside. And so the repair plan was actually pretty ingenious and pretty straightforward. Is we had this big ring that had a lot of bearings that we had to remove the bearings. We had to clean up metal debris that was crushed metal and put new bearings and put some grease down. Well, grease doesn't behave very well in space. And so if you notice in the bottom of the page, there's a little toolbox. Well, that's actually my partner's toolbox because there's my toolbox. Yes, I had a failure on orbit of a lost tool bag, and it did cost $100,000, which is a good demonstration of how, when you're working in space, you have a lot of things to keep track of and figure out what you're doing. And you've practiced it, so you're very confident that you know what you have to do. But you go outside and something happens that you didn't anticipate. In my case, it was one of these grease guns was leaking a little bit, and this was not a good thing. So I called the ground. And I started cleaning up the tools. And, you know, all my tools are in a big box. And I'm going through everything inside and everything is all hooked up. And the very last thing I picked up was this tool bag. And I didn't even notice that the string was not attached. I wiped it off a little bit and let it go. And then it started floating away. And so what do you do when your tool bag floats away? For a minute, I thought, should I jump and catch it? No, that would just make the situation worse. And at that point, all I could do was call the ground, tell them what happened. And then I had to tell them, what are we going to do about it? My partner started talking to me saying, hey, you know, we got to figure out a better way of doing this. I'm using way too much grease. So I said, okay, we've got mitts to use. We can clean up. We've got plain wipes, wipe everything up, put a new bearing, put new grease, and button it up. And you know what? We got everything done in the same amount of time. And so the important thing is that, yes, we did fix the space station and they got it back into operation. The bad news is there was an extra tool bag that spent 9 months in orbit, but it's no longer there because things don't stay in orbit forever and it decayed. But in space, you know, we do get to have some fun. This is the International Space Station. This is the front of it. And you can see how big that space is. It's a pretty big space rotating around in there. And this is the shuttle's middeck. This is where the shuttle crew, we eat, we sleep, and exercise, very important. You want to stay healthy in space. And we got to have Thanksgiving on orbit. There's our delicious Thanksgiving dinner. And then one of my crewmates did something pretty ingenious. He made a cup that the liquid doesn't float out of. And so he's able to enjoy his tea up in space. And then at the end of the mission, we left our patch on the space station. And there's my fun picture from space. Yes, long hair was not very practical. That was on my first mission. My second mission, my hair was half as long. But you know, the thing that we like to do the most in space is just look out the window, is look back at our beautiful planet and just marvel at how wonderful it is. And looking out at the horizon, because we don't see the Earth as a ball, we're not far enough away. You do see a curvature of the Earth. And you see a blue line that gets thinner and thinner. And that's our atmosphere, and that's what protects us. So it's really important to protect our planet. And then we also get to look down and try to identify where we are. Here's a picture that I found that this was not our mission, but I hope you guys recognize this because, yes, this is Chile from space. You can see the mountains, the Pacific Ocean on the right-hand side, and then on the left it goes towards land and then the Atlantic Ocean. But the space shuttle wasn't intended to stay up in space for long periods of time, so we have to eventually come back home. And then on landing morning, when we get the go-ahead from mission control, then we can get everyone dressed. And then those of us on the middeck will get ourselves dressed, get strapped in. We do a deorbit burn, which is what takes us out of orbit. There's mission control down in Houston. And if you saw the map on there, the line went to the West Coast. Ideally, we like the shuttles to land back in Florida where we launch. But for STS-126, the weather was poor in Florida, so we landed in California. You can see it's a beautiful sunny day. Lands very much like an airplane, but one big difference is that we have no engines. So we're really a big glider. We have one opportunity to land. Most of the flight coming in is done with the computer controlled, but the commander does take over and fly it. And this is what he's looking at outside his HUDs. It's just giving him readings of altitude and speed. So 240 knots at 40 feet. That's much, much faster than a regular airplane because we're a heavier airplane and we have much smaller wings to generate sufficient lift. So we just come in faster to compensate for that. Once we touch down, then we can go ahead and deploy the parachute. It helps us slow down, take some of the load off the brakes so the brakes don't get too hot. And so once we've got down below a certain speed, we can go ahead and jettison the parachute because it's no longer efficient and it prevents it from getting tangled up in the main engines. And so we'll go ahead and roll out to the end of the runway. We'll give a wheel stop call to mission control, and we start shutting down equipment before anyone can come out to relieve us and help us get out of the vehicle. And then we get used to gravity again. And I can tell you that the longer you spend in time, the harder it is to get reacclimated. And so folks that spend 6 months in orbit, they have a much, much harder time getting reacclimated to Earth's gravity. But again, human body is pretty amazing and we all adapt. And so that's my story. I hope you enjoyed listening to it. And I challenge you to start thinking about what's your story going to be, because I have no doubt that if you put your mind to it, that you will have incredible careers, whether it's in space or some other industry. But just remember, it all starts with math and science. Thank you.